All right, today we're going to be covering the ALL TEST 7 Pro. In the box, we have our download certificate, calibration sheets, manual, things like that. The carrying case is included with the instrument. On the left-hand side here, we have our ALL TEST 7. The data communication cables are white cable here for uploading and downloading tests to and from the software and the instrument. Our oil filter remover, which we use for spinning the shaft in our rotor stator health test. It's a dynamic test that we take. Our black plug for charging, our key dongle for license within the software, and a couple sets of test leads. These are the larger test leads that actually come with our ALL TEST 7. They are color-coded black, blue, and red, and our yellow one for ground. We do have a smaller set available as an option that can be added at any point. We do recommend them. These are the ones that actually come on our ALL TEST 34 instrument, and they provide a little bit more flexibility when you have different size leads that you need to connect to. And again, those are included with our ALL TEST 34, not our 7. Our ALL TEST 34, if you're interested in that instrument, is designed for de-energized testing of three-phase AC motors under 1,000 volts. We have a separate video covering that on our YouTube channel. But again, today we're going to be talking about the ALL TEST 7 instrument itself. So we're gonna get into the instrument a little bit. On the actual interface of the instrument, you have numbers, alphanumeric keys up on the top hand side of the instrument. That's just for entering motor data when we save our tests. And in the top left corner is our on button. It's going to turn on the instrument. And once we first boot up, it's going to give us a warning just saying that we cannot connect to live power, as this is a de-energized instrument. We do have energized testers, but this is not one of them. We have our yellow ground plug, red, blue, and black test leads, and our data communication cable port, and our charging port on the side of the instrument itself. Down on the bottom, we have our OK key, up and down, left and right toggles, and then the down arrow is actually our test key. On the interface, we have a menu up on top. If I go all the way to the right, it's our power off. Our battery indicators all the way on the right, our settings menu. We have the ability to view and delete tests, set time and date. We also have some manual tests like our resistance induction tests. You can look at your serial number, firmware updates, firmware versions, things like that. And if I back out of here and get back to the main menu, you can actually hold down the bottom arrows on the instrument to get back to the main menu. The INS test is our installation ground test. It's a Mager test. That's just one individual test itself. Then our dynamic test is our rotor stator health signature test. Again, that's an individual test. And then as we scroll over to the left from there, that is our IND test. And that's for three-phase AC motors under 1,000 volts, uninstalled. So uncoupled motors where we have access to the shaft. As we scroll down to our Z-Fi test, that's the one we're going to do today. That's designed for three-phase AC motors, no matter what the voltage and horsepower is, that are installed. That's our installed test. And that's going to be something that we're going to do in a bit here once we actually get started taking a measurement on the instrument. Our next menu over is our DC motor test. And then we have our manual test. So this will be for our single-phase motors. And we have a couple other tests that we can do under that menu, and our routing feature. So there's a route capability in both the 34 and the 7 for creating a route on the database, bringing it into the instrument, and walking through a route, taking tests, whether they're spare motors or motors within the plant that you can connect to at the drive, at the motor leads, or at the MCC bucket, as long as they're de-energized. And then on the bottom right-hand corner is our communications to the computer. I'm not connected to the computer, so it's just going to be waiting. So that would be where we would send our test to and from the instrument itself. All right, now we're actually going to walk through and take a test. Again, here's our interface. We're going to go down to the Z-Fi test. Again, this is for installed motors, three-phase motors. You can do transformers as well, but we're going to select the motor because we're actually going to test my demo motor here. So I'm going to select motor and hit the OK button, and it's first going to tell me to connect the blue clip to phase 2 and yellow to frame ground. So I'm going to grab my leads and connect them into the top of the instrument, blue into the blue, which is our phase 2, and yellow into frame ground. And we'll clamp these on the leads. Make sure you take caution in connecting these to the leads. They need to be seated properly to have proper contact with our clips, our leads themselves. So all I'm going to do here is hit the OK button and move forward onto our next menu. Our next menu is a dissipation factor and capacitance test. This is something that we have as an indicator of early contamination warnings. So we're going to go through and we're going to select that test. This little light down in the bottom right-hand corner is just telling us that it's in the middle of a measurement right now. Now, right now we have our dissipation factor, which is up on top, and capacitance, which is measured in nanofarads. We're just simply looking for something outrageous, outlandish, 200, 300%, or no reading, out of range, something like that. We have our own internal alarms here that are set, so I'm just going to continue to hit OK and move on to the next menu, which is our insulation test. So this is the same as our Mager test, excuse me. So what we're going to do here is toggle between 500 volts and 1 kV. I'm going to do this from 500 volts. And all I'm going to do is hold the test key down until I get a stable reading. And again, that light is on. I hit the OK button and I save that measurement. Now it's going to ask me to connect the remaining leads, black to phase 1 and red to phase 3. I do have mine labeled on the motor, just so if I have anything that indicates an issue in one of the phases, I know which one to look for. So I'm going to connect these, and once I'm done with that, I'm going to walk through and hit the OK button once I'm done connecting. And now I'm in the middle of a measurement. So this is our static test between phase 3 to 2. It'll then jump to 2 to 1 and then 1 to 3. So it's going to test individual phases on the instrument itself and output some results. Now the results that we're going to get on this last menu are going to be in OK, warnings, and bads. Just for quick diagnosis, again, those are internal alarms that are set proprietary to ALL TEST. And again, we can get more value out of those results by looking at individual tests. So we'll have a resistance reading, an impedance, an inductance, a current frequency response, things like that. We can actually look at the results themselves and compare them between the phases. But if it's somebody that isn't an electrician or doesn't speak motor testing lingo and just wants to be able to take a really, really quick test on a motor, you have OKs, warnings, and bads to point you in the right direction. So right now we have OK up on top and resistance. I have contamination, insulation, phase angle. Everything shows up OK on here. So that's pointing to this being a good motor. If I tap on any one of these, I can hit OK, and I'm going to look at my resistance reading in each phase, 3 to 2, 2 to 1, 1 to 3, and then my deviation from average down on the bottom. And that's essentially what we're doing with the instrument is comparing the measurements between each phase in the motor. And as I scroll down to contamination, we saw our measurements in dissipation factor and capacitance. Everything checked out there. Insulation, we had 500 volts. Tested at, and then we're down here to phase angle. And again, our deltas are down on the bottom. Current frequency response is our next measurement. And again, our deltas between the phases. So what I'm going to do here is I'm going to go down and actually look down at the save and reference down on the bottom of the instrument. I'm going to store this as a good motor, and I'm actually going to take some results after this and compare them to the new one. So I have a save option, which is going to be very elaborate. It's going to ask for the model number, the manufacturer, the horsepower, the voltage, things like that, and I can store that as a detailed test that I can bring to the software. But for this one, I'm just going to do a save as a reference because I'm actually going to take a test a little bit later here and compare it to the reference, which is our next mode down from this reading. So all I got to do is name the motor. I'll just do an ABC motor, and then I'll save it. I'm going to go up to next and hit OK. And my motor data is saved as a reference. All right, so now we're going to do a second test on this motor. And what we're going to do is we're going to speed through here and get into my Z-Fi test. And I'm going to simulate right now that we took a baseline measurement. We stored that first reading as a reference. And what we're going to do is walk through this motor and run a test again and compare the values that we get in this motor test to our previous one. So I'm going to speed through this real quick because I've already shown you how to use the instrument, at least for the Z-Fi test, connect to my motor. And what I'm simulating here is that we had a motor that tripped the drive in the plant, and we're trying to know immediately, do we have a problem on the motor? Is it the motor? What is it in the motor? Or is it something else that we need to look into? And by connecting either to the leads, to the drive, or the MCC bucket, and I walk through this test, I'm going to compare my measurements from this test to my past test, which is a baseline measurement on a good motor, on the motor when it was good, when it was brand new coming from the supplier or the motor shop. And we're going to compare the measurements between this test and the previous test. And we're going to use that via our test value static number. That's our TVS value on the motor that we took earlier. And that number is a patented algorithm that ALL TEST has, which is a sum of all the 6 electrical parameters that were taken on this instrument, and it's assigning a number. It's not good, bad, or indifferent. It's just a number. I think we had about 658 on our previous test for the motor. It doesn't really mean anything, but what we're looking for is a change in that number. And what we can do is compare same model, same manufacturer, and horsepower on a motor, whether it's the same motor or an identical motor, and look for changes. And the changes are going to indicate something is changing electrically and indicating an early stage of a problem, or we can use it to eliminate false positives due to rotor position on an installed motor. So as we walk through the test, we're going to compare our TVS value really quickly between our old test and our new test, and we're going to look for a change that is outside of 3% from our original number. So if it was 658, we want to look for something outside of 3% that's going to indicate we have a problem and we need to pull that motor immediately. So as I scroll through here, I have some okays, I do have some bads, so I know something's going on. I know that my new TVS is 716.13, so I don't know, exactly what that is in math terms. It's probably outside my 3%, but if I hit okay and I go to compare this test to my previous test, and I go to use my motor ABC that I saved earlier, and I use it, I know immediately that my TVS deviation is outside of 3%, and I have a bad motor. I need to replace that motor, put a new one in, and go from there. And in a matter of only a minute or two, I know that this motor is bad. Making a very quick decision is going to save a lot of money. Hey folks, Eric Fritz with I&E Technologies here. Thanks for watching the video. If you enjoyed it, give us a like or subscribe to our channel. If there's anything that we can help with, please visit our website, give us a call, or shoot us an email. We'd be happy to help.